Welcome to qnawire.
Our question says that we have a 10-gram bullet moving directly upward at 1,000 meters per second. So I write the mass of the bullet as m sub b and the initial velocity of the bullet as vb sub I. And this strikes and passes through the center of mass of a 5-kilogram bullet initially at rest. So it's important that we consider this to be the center of mass of the bullet, or the center of mass of the block that is being struck. So the entire block wants to move up in the upward direction instead of at any kind of tilt or angle. The bullet emerges from the backside of the block, moving at a final velocity vb sub I of 400 meters per second, or vb sub f for final velocity of the bullet. And then I also write the mass of the block as m sub t, not to confuse that with m sub b, t standing for target. So the block is the target of the bullet in this case. And it wants us to figure out what height the block then rises to above its initial position. Okay, well, you can figure out that height from energy conservation, but first we're going to need to calculate the velocity, which we can do from momentum conservation. So the initial momentum of the system is just the mass of the bullet times the initial velocity of the bullet, since the target is initially at rest. So its velocity is 0. And this is going to be equal to the mass of the bullet times the final velocity of the bullet, since that's its final momentum, plus the mass of the target times the final velocity of the target. We'll call that Vt sub f. So we can solve for Vt sub f, because we know everything else in this equation. This is equal to the mass of the bullet multiplied by the difference between the initial velocity and the final velocity of the bullet, divided by the mass of the target. And we converted the mass of the target from kilograms into grams, so we can compare that with the mass of the bullet here. And since there's 1,000 grams in every kilogram, it's 5 times 10 to the third grams. So you plug those values into this expression, and it comes out to be 1.2 meters per second. Write that a little neater. Okay. Well, now that we know this, we can use energy conservation, which says that the initial energy of the target, we'll call that U sub t, is going to be equal to the final energy of the target. So the initial potential energy of the target is going to be equal to the final kinetic energy of the target, since we assume it's at rest initially and it's in motion in the end. So m times g times h is the initial energy, or the potential, is going to be equal to 1/2 m, and this is the mass of the target here, right, times the final velocity of the target squared. Okay, well, the masses are going to cancel, and we can solve for h. H is equal to 1/2 times the final velocity of the target squared. Let's write this a little closer so we can fit it all here. Final velocity of the target squared, divided by the mass of the target, or divided by gravity, right? Because the mass is canceled. And gravity here is equal to 9.8 meters per second Okay. So if you plug all those values into this expression, this comes out to be 0.073 meters. And we can box that in as our solution.